Good day friends, welcome to System Cog YouTube channel. In this tutorial, I'm going to be teaching how to use Proteus to simulate the Thevenin circuit. So we are going to be simulating this circuit using Proteus. This circuit was gotten from Fundamentals of Electric Circuit by Alenxander and Sadiku. This circuit is the practice problem 4.8 in the text. What we're going to be finding in this circuit is the Thevenin equivalent circuit and the current that flows through the load. Solving this circuit, the first thing we're going to find is the equivalent resistance. So the equivalent resistance, which is known as the Thevenin's resistance, can be gotten by removing the load, which is this 1 ohms resistor. Then for the current source, we're going to remove it, we're going to replace that with an open circuit. Then for the voltage source, we're going to replace that with a closed circuit. So doing that, you're going to get a similar circuit like this. So from here, we can easily find our equivalent resistance. So the equivalent resistance here, it's going to be our R1 and R2 is in series, so we're going to sum that up. Whatever we get is going to be in parallel with the R3. So here is the calculation. The Thevenin's resistance is equal to 6 plus 6, which is in series, then in parallel with 4. So that's going to give us 3 ohms. Now, having gotten the Thevenin's resistance, we're going to find the voltage drop across the load. Now for you to get that, you have to remove the load. You have to remove the load and bring back the current source and the voltage source. Doing that, we're going to get this kind of a circuit. So here, using Kirchhoff's law, we are going to find the voltage on this node. Our aim here is to find the voltage across this terminal. So the voltage across this terminal is same as the voltage across our 4 ohms resistor. And how to get this, we need to get this first. So using the Kirchhoff's law, we're going to assume that current is flowing to the node. Current from I1 is going towards this direction, current from I2 is going towards this direction, and current from I3 is going towards this direction. So we're going to have an expression which says I1 plus I2 plus I3 is equal to 0. That is Kirchhoff's current law. So what's our I1? Our I1 is the voltage which is this minus this divided by 6. So 18 minus V1, the V1 is this, the voltage, this node voltage. 18 minus, sorry, that's minus, not plus. 18 minus V1 divided by 6, that gives you I1, that is Ohm's law, plus I2. I2 is 3 amps, plus I3. I3 is reference voltage minus V1 all over 10. Now our resistance is 10 because R2 and R3, they are in series, so we're going to sum that up, giving us a total of 10 ohms. So solving this, we're going to get 22.5 volts as V1. So the node voltage here is 22.5 volts. So to get this, we're going to use the voltage divider to get this. So what we're going to do to get this is we're going to say VR3 as VR3 so the voltage drop across R3 is equal to 22.5 times 4 over 10. Now this 4 is the resistance, is R3 resistance, while 10 is the total resistance, That's 6 plus 4. So we're going to have 9 volts as the voltage drop across the 4 ohm resistor. And remember, the voltage across the 4 ohm resistor is same as the voltage across the load. So that means our Thevenin's voltage is going to be 9 volts. Now, having gotten this, we're going to replace the whole circuit with the Thevenin circuit, which is this. So our voltage source will be replaced with the Thevenin's voltage source, which is 9 volts. Then our resistance is going to be replaced with a single resistance of the Thevenin resistance, which is 3 ohms. Then we're going to connect our load. So what we're going to be doing in this circuit is to find the current flowing through this load. So finding the current flowing through this load, it's very simple. Now the current flowing through here, it's same current that flows through here because the circuit is in series now. So what we're going to do is we're going to use our Ohm's law, which says I is equal to V over R. So our V is 9 volts and our R is 3 ohms and 1 ohms, which is in series. So adding both of them is going to give us 4 resistance in total. So 9 divided by 4, we're going to get 2.25 amps. So this is what you're going to get when you analyze this circuit mathematically. So we're going to use our Proteus simulation software to see if this result is same with what we solved mathematically. Let's quickly open up the Proteus and let's start the simulation. This is the Proteus environment. We're going to start with picking the components. So first of all, let me zoom in. Then I'm going to click on P to pick component. So I'm going to be using Vsource and Csource. So I can do it this way: Vsource to get the voltage source, Vsource. So this is the voltage source. Then I'll type Csource for current source, or you just type DC source. DC source is going to give you both the voltage source and the current source. I'm going to double click on the voltage source and the current source. And we're also going to need the resistor. Resistor. This is the resistor. I'm going to double click on it. Then I'll click on OK. Okay, so what I'm going to do next is to draw the circuit. I'm going to pick the voltage source, bring it up, pick the current source, bring it up. I'm going to mirror this because the arrow is facing upward, so I'm going to use Y mirror. Then I'm going to bring the resistor, place one over here, place the other over here. We still have another one which is around here, and finally the load. So I'm going to rotate this, same with this. Okay, so I'll start wiring the circuit. Okay, then I'm going to change the value. This is 18 volts. This is 6 ohms. This is 3 amp. This is 6 ohms. This is 4 ohms. Why this is 1 ohm. Okay, so next is to bring the ground. Place it here. Okay, so I'm going to get the DC amp meter. So the DC amp meter is going to be used to calculate the current flowing through this load. Or I can equally use the current probe, whichever one you want to use, you're going to get the correct answer. So let's just bring in the DC amp meter to place it over here, and also let's bring in the current probe. Let's use the both of them. But while using the current probe, you have to be very careful. Make sure your current direction is facing the right place. Okay, so that will be all. So what we're going to do next is to run the simulation. Let's see if we're going to get the same current as this. So here I'm going to start the simulation. Okay, as you can see, I'm having 2.25 amp. Same thing with the current probe, 2.25 amp. That's to say that our result here is verified, so it's correct. So what I'm going to do next is I'm going to verify if our Thevenin's voltage is 9 volts, same thing as this. So for you to get that, for you to be able to get that, we have to remove we have to stop the simulation first, then remove the load from the circuit. Then we're going to bring in our voltmeter, which is under this DC voltmeter to be precise. Place it over here. Then we'll run the circuit. So as you can see, we have 9 volts across the terminal, and if you take a look at the amp meter, notice that it's 0. Current is not flowing through because it's an open circuit. Same with this. Okay, so our Thevenin's voltage is correct. So next is we're going to verify if our Thevenin resistance is correct. So for you to get this, we have to obtain this equivalent circuit. So what I'm going to do in Proteus is I'm going to remove, I'm going to stop the simulation first, and I'll remove this, I'll remove this, same with this. I'm going to remove this, then this will be replaced with a short circuit. So let's redraw this. Okay, let me see. Okay, this is correct, and don't forget we are having a terminal over here. Okay, so what's going to be the total resistance? How are we going to get that? So to get the total resistance, we have to pick a component which is called the ohm meter. The ohm meter, which is this. We're going to click here. So our ohm meter value here is 3 ohms, and same thing with what we have over here. And this is to say that our calculation is correct because the simulation and the calculation is giving us same value. That will be all about Thevenin circuit. See you in the next tutorial.